Welcome to DozoChem. This video covers determining empirical and molecular formulas from percent composition by mass and molar mass. Let's start with a couple of definitions. The first is molecular formula, which tells you the actual number of atoms of each element. And then we have empirical formula, which just tells you the simplest ratio of atoms of each element. So down below we have an example. Here's the molecular formula of glucose, C6H12O6. So that's telling you the actual number of atoms of each element in a molecule of glucose, whereas the empirical formula just tells you the simplest ratio, CH2O, or a ratio of 1 carbon to 2 hydrogens to 1 oxygen, but not the actual number of atoms. Now, it turns out if you know the percent composition by mass of an unknown compound, you can figure out the empirical formula, but we're going to use an alternate definition of empirical formula when we go through this. Rather than saying simplest ratio of atoms, it's also the simplest ratio of moles of each element. That'll be helpful when we go to do this method. So here's some data. Imagine you have an unknown compound and they tell you the percent carbon and hydrogen by mass, and they also tell you that the rest of the compound is oxygen. So we know we can just take 100% minus the percentage of carbon and hydrogen to figure out the percentage of oxygen in the compound. Next thing you want to do, step one, you want to assume you have 100 grams of compound. If you do that, then the percentages become the number of grams of each element in the compound. Step two, convert grams of each element to moles. So from the previous slide, we knew the grams of carbon, hydrogen, and oxygen. We're going to divide by the molar mass of each to figure out the number of moles of carbon, hydrogen, and oxygen, relative number of moles in the compound. Now at this point, we could write a formula with the number of moles of each element, but we want a whole number ratio. So the way you're going to do that is look at the three numbers next to the three elements and divide all of them by the smallest in the group. So in this case, 3.221 was the smallest, so you divide them all by that number, and that will convert your formula to a whole number ratio, CH3O, or 1 to 3 to 1, 1 carbon to 3 hydrogen to 1 oxygen, and that is your empirical formula. Now, it turns out if you're also given the molar mass of the chemical, you can figure out the molecular formula as well. What you're going to do is take the molar mass, in this example 62 grams per mole, and you're going to divide by the mass of the empirical formula, and that should give you an integer, which we can call x. So if the molar mass is 62 and the empirical formula from the previous slide, CH3O, adds up to about 31, you'll see the ratio of molar mass over empirical mass is 2. So last step is simply to multiply the subscripts in your empirical formula by x, which in this case is 2. So that would give us the molecular formula of C2H6O2. And you'll see if you add up the molar mass of that, it does in fact equal 62. So that's how to figure out empirical and molecular formulas from percent composition by mass and molar mass. That's it for this video. Good luck.